Good morning, dear friends. I am Dr. Linus from School of Electrical and Communication Sciences at JSPM University, Vagoli, Pune. In this playlist, we are going to learn about the importance of the virtual lab, especially for electrical engineering. In this today's session, we are going to learn about how one can experimentally do this Kirchhoff voltage law verification through this experiment in virtual lab. So in this website, we have to should know the domain of this website, www.vlab.co.in. So this virtual lab is formed by, it is an initiative of this Ministry of Education with the help of the reputed institution faculties. And if you go below that, you can see the objectives, everything. We are moving directly to this electrical engineering lab. So here you can see the different labs are available for different people. So first let us go now this basic electrical science lab. Our aim is to go and learn this learn the Kirchhoff voltage law. So if you see this basic electrical science, wherein we can find the list of experiments. Under this, the second experiment is to study and verify the Kirchhoff law. So if you go inside, you can see the different things: theory, preset, procedure, simulation. Everything will be available. So if you want to know about the Kirchhoff voltage law, we can go through this theory and we can understand. Already we know that sum of the total voltage drop in the closed path is equal to 0. That is the definition of the Kirchhoff voltage law. So let us go to now the simulation. So when we go to the simulation page, we can see here Kirchhoff voltage law as well as Kirchhoff current law. So we can click now Kirchhoff voltage law. So in this case, we can see there's different values, resistance R1, R2, R3. We have to fix ourselves. So this is the simulation environment wherein we have the power supply, 3 voltmeters are connected, and the circuit is like this, R1, R2, R3. So when we fix this resistance, if we vary this resistance, automatically these values of the resistance will be vary. It will be shown in this small box. So now we are going to connect now this entire connection. So now this positive and negative terminal we are connecting to this power supply. So this is positive and the negative terminal. Then we can connect this voltmeter across each resistance. So V1 is connected across R1. And R2 is connected, V2 is connected across R2, and the voltmeter V3 is connected across R3. So this much only the connection circuit. So we have completed the connection. So after completing the connection, we should check whether the whatever we connected are correct or not. So we have to be checked. So automatically we will see one small window will be pop up where we can see the right connections. Please choose the resistance values. Now I am going to choose the resistance value. First resistance will be around 2 ohm, and second resistance you can see now around 4 ohm, and R3 I am going to choose this 6 ohm. So yes, now we have selected. So already we know R2 and R3 are parallel. So the voltage across R2 and R3 are same in the parallel connection. Already we know that. Then in this resistance R1, so this is one small loop. So we are applying here some voltage. That voltage is nothing but sum of the total voltage of this voltage across resistance R1 and R2. That's what we are going to learn. So sum of that, but the total sum of vector sum of the closed voltage vector sum of the voltage drop across the closed path is equal to 0. That is the Kirchhoff voltage law. So now we are giving the supply voltages. We are switching on the power supply, and switching giving to 10 volt, right? So we can maximum voltage variation is from 0 to 10 volt. Automatically you can see the voltmeter will also display accordingly. Now what we are going to do, first here the resistance is R1 2 ohm, second one is R2 4 ohm, and third one will be 6 ohm. Now I am going to apply, the voltage is around 2 volt. This we can take the tabulation as well. I will explain to you one by one how to do it. So now I have given 2 volt. So in this time automatically voltage drop across these two resistance will be increases. So same way the voltage, as I told you already, voltage drop across resistance R2 is same as voltage drop across R3 since R2 and R3 are parallel. Okay. So now first I have given 2 volt and I am observing the reading. So you can see here add. Automatically we can see first reading. This tabulation only observe maximum of 6 reading only. So now I am going to make now 2, 4 voltage. I am going to increase 2, 4, 6, 8 and 10. So like that 5 readings. Even possible in between we can take one more reading. Maximum allowable will be 6 readings only, right? So now we have applied 2 volt. See now already I told you V2 V3 both are parallel, since R2 and R3 are parallel, therefore two voltages are same, 1.1 and 1.1. At the same time here the V1 will be 0.9. So if we add both 0.91 plus 1.1, we will get approximately 2 volt, right? 2 volt. Then now I am going to increase this voltage to 4 volt, and the same procedure I am doing, add the tabulation. So now 4 volt, here 1.8 and 2.2, the sum will be 4 volt, right? So the same thing, concept is same, V2 and V3 are same. Then now we are moving to 6 volt. 6 volt, and we have to minutely vary, then only it will be, voltage will be very properly. Then we have to be added. So 6, then we can move to 8 volt and we can add it. Then see, if you see V1 plus V2 will be total voltage, supply voltage, right? Then I am going to make 9 as well as 10, 9 volt. I will add the values and 10, then I will add the values. So now see here, many things we can learn from this. I already told you parallel connection voltages are same, we are learning. Then here resistance R1 is 2 and resistance R2 is 4. The voltage across the resistance is less, voltage drop will be less, right? The resistance is more, voltage drop will be more, like that. Here the resistance is 0.9, here resistance is 2 ohms, therefore the voltage will be 0.9. Here the resistance is 4 ohm, therefore voltage will be 1.1. Like that in all the cases V2 is higher than V1. V2 is V1, otherwise V1 is less than V2, since the resistance of R1 is less than resistance of R2. Then finally we are going to plot the curve. So for that we can click this plot. So we can see this is x-axis will be the supply voltage and y-axis will be the two voltages V1, V2, V3. So V2, V3 are same, therefore this green and orange color are in the same axis, V2, V3. So now if you see here 4 volt, the 4 volt for example supply voltage is 4, therefore 4 volt, 1.8 and 2.2, the total will be 4 volt, right? So we can see 1.8 and 2.2 volt. So like that we can see the graph. So this way we can easily understand how one can do this, verify this Kirchhoff voltage law. I hope this is very much interesting to you. Those who have not subscribed this channel, kindly subscribe and like it and share as well. Wish you all the best. Thank you.